In this video, we will introduce the analog communication systems. In an analog communication system, the information signal that is called the modulating signal, M of t, is an analog signal. The information is in a continuous time waveform like the one that we have in this picture. And typically, this is a baseband and bandlimited signal. The bandwidth is W and the spectrum is centered at 0. There are several types of transmission in analog systems. It is possible to have a baseband transmission and modulate it to transmit the information signal as itself, but the most usual option is to modulate this signal. And modulation has a first implication. When we modulate a signal, typically the spectrum of this signal is shifted. Sometimes the shape is maintained and the only effect is frequency shifting, but in some other cases the shape can be modified and the spectrum can be spread. The bandwidth can be higher than the original bandwidth, like in this case. There are several reasons to modulate an analog signal. The first one is to adapt the signal to the characteristics of the channel. Taking into account the frequency response of the channel, the spectrum of the modulating signal is shifted to the frequency band that is more appropriate for the transmission or the frequency band that is available, because in many applications the bandwidth is a very scarce resource. Another reason is to expand the bandwidth of the signal, and the expansion of the bandwidth has a purpose. The purpose is to increase the noise immunity of the modulated signal, to reduce the effect of the noise during the transmission of the signal. And the third possible purpose to modulate an analog signal is to transmit simultaneously several signals in the same medium. This is called multiplexing or medium access. In this case, if we use the modulation to multiplex or to medium access, the technique is called frequency division multiplexing, FDM, or frequency division multiple access, FDMA. Now, we are going to see the main idea of this type of multiplexing or medium access. The basic idea of frequency division multiplexing, of FDM, is to shift the spectrum of different signals to non-overlapping frequency bands. If we have 3 baseband signals, for instance like these ones, and we have the available spectrum for transmission, we can take one of the signals and we will shift the spectrum of this signal to a given frequency band. Then the spectrum of the second signal will be shifted to another frequency band that is non-overlapping with the first one, and then we can move the other signal to another frequency band that is not overlapping with the previous frequency bands that were used by the previous signals that were modulated. A classic example of the application of FDM is commercial radio. Several radio stations can transmit at the same time if they shift the spectrum of the transmitted signal to different non-overlapping frequency bands. Each radio station has assigned a frequency band, and when the user wants to listen at a specific radio station, he only needs to tune the radio to this frequency band. When somebody is selecting one of the stations by tuning this station at the receiver, what we have is that the spectrum of this signal is filtered, and then the spectrum is shifted back to baseband, and the listener can hear the selected radio station in this example. If we have 3 radio stations and we tune this one, then the frequency band assigned to this station is filtered, and then the spectrum in this band is shifted back to baseband, and we'll have the voice signal now in baseband ready to be listened. If somebody else is selecting another radio station, this frequency band is filtered, the spectrum is shifted back to baseband, and if another user selects another radio station, the corresponding frequency band is filtered and the corresponding voice signal is shifted back to baseband. This is how FDM works. Taking into account that the signals have the spectrum shifted to non-overlapping frequency bands at the receiver, it's possible to separate them without any problem, just by filtering and a shift of the spectrum back to baseband.